In 1869, a certain Russian scientist got interested in elements and he started arranging this element, giving rise to what is known as the periodic table. And the name of this scientist is known as what? Dmitry Mendeleev. Dmitry Mendeleev. Dmitry Mendeleev. This man gave rise to what is known as the word periodic table. But there was something he was doing wrong, right? Dmitry Mendeleev was arranging this element in order of their what relative atomic what mass. He was focusing on the arrangement of elements in the order of their relative atomic what mass, and he had a lot of what loopholes. And as time goes on, leading to the discovery of the what electronic what structure, we got to find out that these elements cannot be arranged in order of their relative atomic mass, and this also gave rise to what is known as the what modern periodic table. Understanding this topic is very, very essential if you are preparing for your JAMB UTME, preparing for your WAEC, or preparing for any external examination, or even your internal school examination. And I am here to simplify the topic of the word periodic word table. And if you are coming across this channel for the first time, my name is Basi Ejogba. I'm a student in the University of Calabar studying medical laboratory science. And in my channel, I help students level up the academic game. I also share food tips on the channel focusing on personal development. So if you love content like this, please don't forget to hit on the red subscribe button so that you can continue getting updates anytime I drop videos like this, and so that you can help me grow. And just like I said, we are going to be simplifying the concept of the word periodic table. And like I said, this man known as what Dmitry Mendeleev brought about the word periodic word table, but this man was arranging this element based on their what relative what atomic what mass. He was arranging this element based on their what relative what atomic what mass. But with the discovery of the electronic structure of what atoms, we found out that atoms do not vary. We found out that atoms do not vary with their relative atomic what mass. The mass number does not cause atoms to what vary, right? Rather, what led atom, or what led to these varieties of the behavior of these what various what atoms of what element is what is known as what the relative atomic what number, right? The relative atomic what number. It was the relative atomic number that caused the what this element, or the atoms of element, to what vary chemically, right? And this led to this led to what is known as what the modern periodic what table. That means we are no longer following what this man did, Dmitry Mendeleev. We are no longer following what he did, although he set the what foundation, and some of the predictions he made are still what valid. So we are not neglecting him. But what was done, or what has been done, is that chemistry has what advanced, and new discoveries have been what made, and this will give rise to us to talk about what is known as the what the modern periodic what law. The modern periodic law states that the properties of elements, the modern periodic law, the modern periodic what law, the modern periodic law states that the properties of element states that the properties of elements say that the properties states that the properties of elements state that the properties of elements state that the properties of what elements are a periodic function, a periodic function, a periodic what function of their relative atomic number, of their what relative what atomic what number, of the relative atomic what number, right? And no longer what periodic function of the what relative atomic mass as proposed by what Dmitry Mendeleev, right? So from here we are also going to be talking about what the electronic what configuration. So the electronic configuration is simply the what arrangement of these what elements, right? Is simply the what arrangement of what the elements around their what orbitals. That means the electrons of this element in the what orbitals. We already know what the orbital is all about, right? When we see cycle like this in chemistry, these are what are known as the what orbitals, and we say that the orbitals is what a region of what space where there's what a 98% probability of finding what an electron. That means when we see an orbital, there must always be what an electron around this what orbitals, right? So that is what electronic configuration is what trying to what tell us what about. And we are going to be talking about the maximum number of what electrons for the KLMN what shell, right? We are going to be talking about the maximum number of what electrons that are needed for the maximum number of electrons, right, that are needed for the what the KLMN what shell, right? Take note of what is here, shell, right? Because we are going to be specially discussing about what shell. How come we are talking about what shell? Is it foul eggshell or which of the word shell? But we are going to be talking about it. So the periodic table is a very interesting what concept, right? So for the shell, we have the Kell shell. The Kell shell must contain a maximum number of what two what electrons. So we are going to say shell. Please screenshot this so that you can be able to copy it. We have shell, we have their what energy level. We have shell, we have their what energy level. We have their what maximum number of what electrons. We have their what max number of what electrons. That means how many electrons this shell can what contain, right? Which is the what orbitals, right? Which is the what orbital. So we have what our K, L, M, N, right? Note that to calculate this, we are being given a formula which is what 2 raised to power n raised to power what 1, right? Okay, let's say power what 2, sorry. So this is our 2 and let's say power what 2, right? So we have our K, which is what energy level what 1. So applying this, what we are simply going to get is what 2 raised to power 2 times what 1. What we are going to get is 2 times 1 raised to power what 2. So this is what 2, this is 3, and this is what 4. So this is 2 raised to power 2 times 2 raised to power what 2, 2 times 2 raised to power what 2, and 2 times 4 raised to power 2. And we already know that this is going to be what 32, this is going to be what 18, this is going to be what 8, and this is going to be what 2. So that is a maximum number of electrons. That's the maximum number of electrons that can be occupied by what a shell. So this is going to give us something like this. This is going to give us something like, so the innermost contains what 2, right? So this is what we are going to have, right? This is what 8, right? And if you continue, right? So to get this again, the third shell, this is 1, 2, 3, 4, 5, 6, 7, what 8, right? So this 8 plus 8 plus 2 is going to give us what 18, and that is how what it goes, right? It's very, very important that you understand this. So right now we are going to be talking also about another important concept when it comes to the what periodic what table, and that is what is known as what groups and what period, right? The groups and the what period. The groups and the period is very, very important because enable us classify where a particular element what belongs, right? It helps us classify where a particular element what belongs. So what is what the groups? The groups is a group, right? Is what the vertical columns of the what element from what 0 to what 7. So this is the what vertical what columns, right? So this is the vertical what columns of the what element, the vertical columns of the what element, right? The vertical columns of the what element. There's a video I'm planning to shoot very soon. I'm going to be dropping the video soon. So the video is going to be about interesting tricks on how you can be able to get the periodic table, to easily remember the periodic table. So I'm going to shoot it. It's going to be different from this video. So this video I'm just going to be touching this concept, but when I drop that video about the interesting concept on interesting ways you can be able to remember the periodic table, I want you to also go and watch it. So that means that you have to watch, subscribe, right? So the groups is the vertical columns of the word elements, right? So elements, please take note, elements in the same group have the same number of what valence what electrons, have the same number, have same number of what valence what electrons. So let's try something like this. Have the same number of what valence what electrons. Let's try something like this. So we have we have our hydrogen, right? So we have our hydrogen to be what 1, right? Let me see whether I have an example here. Okay, we have our hydrogen to be what 1, right? Or let's use our potassium, or let's use our potassium. In fact, let's use our hydrogen. So we have our hydrogen to be what 1, right? Although the hydrogen is one of the elements that the classification gives it has what a dual what classification, right? But when you let's say let's use sodium for example. Let's use sodium for example. So we have sodium 11, right? We have sodium 11. So we have our 2, right? We have our 1, 2, 3, 4, 5, 6, 7, what 8. So this is what 10, and we have our what 1, right? That means sodium belongs to what group what 1. That means sodium belongs to what group what 1. So this is they have same number of valence what electrons. So this is the number of valence electrons that sodium has. Sodium has what valence electron of what 1. So that is why you always see sodium what plus, because it has what an extra what electron, which is just what 1. So sodium belongs to what group 1, and that is how you can be able to get it. You find out that there's also potassium. Try out potassium, you get to find out that potassium also has a valence electron of what 1. So you can say sodium and potassium belongs to the same what group. That is how we are able to get the concept of what group. Then let's talk about period. Let's talk about what the what period, right? So we say the period is a what horizontal what rule. Please take note. We say group is what the vertical what column, right? And we say the period is a what horizontal what row. So we say period. This is the what horizontal what row from number 1 to what 7. Say period horizontal what row. We say the period is a what horizontal what row from number 1 to what 7, right? And the period element in the same what element that in the same period have the same number of what electron what shells. Remember I talked about electron what shells when I was talking about the electronic what configuration, when I was talking about the KMNL, right? When I talk about the KLMN, right? The KLMN. So the same thing that is going to apply here when you're talking about the what period, right? So the horizontal row from what 1 to what 7, and all the elements in the same period have the same what number of what they have the same number of electron what shells, have same number of what electron what shells, have the same number of what electron what shells, right? Let me see whether I can have an example here. I have the same number of what electron what shells. So let's use sodium. Let's use our what sodium. We say our sodium is sodium 11, right? So let's see how we are going to get this. This is 1, 2, right? Right. Let's just get something. We have what this, right? So this is our what sodium. Now when we say electron shells, this is what 1, 2, or 3. So sodium has what 3 electron what shells. That means sodium belongs to what group 1 period what 3, right? So sodium belongs to what group 1 period what 3. That is just how what it is. We have our what we have which other elements. Just try and check out other elements that have what electron shells that are up to what 3. Then when from there you can be able to classify them. Okay, they belong to this particular period and they belong to this particular period. And when you check the number of valence electrons, you can say okay, they belong to this so what group. That is just how you can be able to identify what is known as what the period and the what group, right? So let's also talk about a very important concept of how a periodic table is concerned, which is known as what the periodicity. Right, let's talk about what is known as what periodicity. So periodicity is simply the variation of the properties of elements. So this is what is the this is the what this is a variation. This is a variation. This is a variation of the properties. This is a variation of properties of elements. This is a variation of properties of what element in a regular pattern. This is a variation of properties of elements in a regular pattern of elements in a regular pattern, both down the group and across the what period. In a regular pattern, both down the group, that is down the group, both down the group and across the what period, both down the group and across the period. Please take note, I didn't say both across the group and down the period, right? I said both down the group and across the what period. So I didn't say down the period, right? I didn't say down the period, but I say what across the what period. So that is what periodicity is what all about. Is a what variation of the properties of what element. Why this element have what different what properties, right? Why this element have what different what properties, and there are some things that causes this what. There are some factors that causes this what variation. So I'm just going to list 2, and you list the remaining ones in the comment section. So the first one is what melting and the boiling what point. So the melting and boiling point affect the what properties of what this what elements, and we also have what electronegativity. So we have what melting and boiling point. This is what I have melting and boiling point. I have melting and what boiling what point, right? I have the melting and boiling point, and I also have here what electronegativity. So there are lots of them, and I want you to drop it in the comment section for me to see if you are actually following up this what class, right? So that is just how what it is. And also in the same vein, we are also going to be discussing about a very important concept as far as we are talking about the what periodic what table. First, we are talking about the what periodic table, and that is what is known as the what ionization what energy, and that is what's known as what ionization what energy. You said ionization energy is the amount of what energy, right, needed to remove what or required to remove what one electron from an atom in a mole of gaseous what atom, producing 1 mole of gaseous ions with a positive or charge. Take note, it says ionization energy is the amount of what energy required to remove one electron from each atom in a mole of gaseous atoms, producing 1 mole of gaseous ions with a positive what charge. That is what is known as what ionization what energy. Please go and check it out using your what required and the recommended what JAMB what textbook. So you have what is known as what the ionization what energy, right? So we are not going to dwell much here since I've already read out the word definitions, right? So that is just how it is. If you want to get an in-depth understanding of the periodic table, sign up for our private classes. Signing up for our private classes is something that will not make you break the bank. It's very affordable, and when you sign up for our private classes, you get access to study materials, and you also get access to timely clarifications from our tutors, right? So that is just how it is. And if you need, like I said, if you need an in-depth knowledge of the periodic table or some of the topics I am discussing here, make sure you join our private classes where you will get private lessons, also private classes with our tutors. And I promise you, when you join our private classes, smashing your JAMB UTME is going to be what a walk in the what park. You will score up to 300 plus, score up to 320 plus. This is not something I am just talking about, or it's not something I am trying to frame up. This is something that we have been doing, and we have produced students scoring up to 316 getting admission into medicine and surgery. We have produced students scoring up to 294. We have gotten students scoring up to 260 plus. We have our students in medicine and surgery. We have our students in nursing science, medical laboratory science, radiography, and mention them, right? So this is something that I am promising you that your money is going to be worth every penny that you spend in joining our private classes. So let's continue. So there are trends that what occurs when it comes to the what periodic what table, or when it comes to what the periodic table, that is the arrangement of what this what element, right? These trends are known as what the atomic radius, the ionization energy, the electronegativity, and electron what affinity, right? So I am going to draw a table and say the trend, right, and say across a period. Note that it occurs what across a period and down the word group, right? It does not occur up the group, rather it occurs across the period and down the word group, right? So you have across the period and down the word group, right? So the first one here we have is the word atomic word radius, right? We have the atomic word radius. So for the atomic radius, it decreases across what a group. So the atomic radius decreases what across what a group, and it increases down the word group, and it increases down the word group, right? So when you have your picture of the periodic word table, from there you can be able to get notice of all these concepts. When we say atomic radius decreases down, increases across the period and down the word group, from there you can be able to be getting knowledgeable about all these stuff. So don't just watch this video and say you are done, rather watch this video with the aid of your word recommended word chemistry textbook, which is the NECO Chemistry, Understanding Chemistry, or any of the good chemistry textbook that you know that you would have. We also have the another trend, which is what the ionization word energy. Another trend which is known as the word ionization word energy. So for the ionization energy, it increases across a group, and decreases. Sorry, the ionization energy increases across a period and decreases down the word group. It increases across a period and decreases down the word group. We also have the word electron word electron negativity. So when we talk about electron negativity, this is not a new term, right? Electron negativity is the ability for what an element to receive what electron. So when it receives, it becomes what negatives. It becomes negative, and that is what is known as what electron or negativity. So electron negativity increases across a period. It increases across a period and decreases down the word group. It increases across a period and decreases down the word group. And we also have what electron what affinity. We also have what the electron what affinity. Note that the same characteristics of what electron negativity is the same characteristics of what electron what affinity. Electron affinity is like to give out what is electron, right? While electron negativity is to what collect this what electron. The electron affinity also increases across what a period, and it also decreases down the word group. So that is just how it is when it comes to the word periodic word table. Note that we have various groups and we have various word period. Now the group, like I said, determines the properties, determines the behavior of this particular word element, right? The group determine the word behaviors of this particular word element. We have the word group 1, we have the word group 2, we have the word group 3, we have the word group 4, and the word so forth and so forth, right? And I'm not going to break it down in this video, but I believe in our subsequent videos I'm going to talk about the word properties of these various word groups of word elements, and I believe you are really going to enjoy it. If you love this video and you wish to continue getting videos like this, please don't forget to hit on the red subscribe button, and also share this video to your friend so that they can come here and get value. Smashing your JAMB UTME is very possible when you follow up our series, get your recommended textbook, and make sure you spend your time studying. Until I see you in my next video, always remember that you're wonderful, always remember that you're unique, and always remember that the pace setter, I really love you. Thank you.